Okay, number 21. We have line 1 passes through, let's call it L1, passes through 1, 7 and 5, 5. Okay, so the slope m of the line going through those 2 points is going to be y2 minus y1 over x2 minus x1. So that equals 5 minus 7 over 5 minus 1. And that equals negative 2 over 4, which reduces to negative 1/2. And then we've got line 2, we'll call it L2, that passes through negative 1, negative 3, and 1, 1. Okay, once again, the slope m equals y2 minus y1 over x2 minus x1. Oops. And I keep repeating this because it'll be easier for you to remember if I just keep saying it over and over. That's how I used to memorize these, because I've always hated to memorize things. That might be why I chose math as a major, or one reason why. Because when you get into more advanced mathematics, you don't really have to memorize so much, but it's all logical reasoning, which I love. Alright, I don't like to memorize, but there is a certain amount of memorization in mathematics, no doubt about it, and there's no getting around it. Okay, so I just keep saying it over and over again, and when I did my homework, I just kept writing everything down just the way you see it here, and that was a relatively painless way for me to memorize these things. Just repetition. And if you hate memorizing like I do, you might want to try that. Okay, so we've got 1 minus a negative 3 over 1 minus a negative 1. Okay, 1 minus a negative 1. So this is 1 plus 3 is 4 over 1 plus 1 is 2, and that equals positive 2. Notice that these are negative reciprocals of each other. The reciprocal of negative 1/2 is negative 2 over 1, or negative 2, and the negative of that is positive 2. So yeah, reciprocal of 2 is the same as reciprocal of 2 over 1. Flip that over, you get 1/2, and take the negative of that, you get negative 1/2. So yeah, they are negative reciprocals. And one more check, if you multiply them, 2 times negative 1/2, you get negative 1. So that means they're perpendicular. Perpendicular. There you go. Number 23. We have line 1, or L1, which passes through 2, 5 and 5, negative 1. So slope m of the line going through those 2 points is equal to y2 minus y1 over x2 minus x1. I should say y sub 2 and y sub 1, x sub 2, x sub 1 to be proper, but it's so easy just to get by with y2 and y1. And since we understand the context here, I don't think it's going to cause any confusion, so I just do it that way a lot. Let's see, negative 1 minus 5 on top, and below we've got 5 minus 2. So we have negative 6 divided by 3, which equals negative 2. Alright, we have L2, line 2, that goes through negative 3, 7, and 3, negative 5. Alright. So once again, slope m equals y2 minus y1 over x2 minus x1. Saying sub all the time, y sub 2, y sub 1. Kind of drives me crazy too. So we've got negative 5 minus 7 in the numerator, and in the denominator 3 minus a negative 3. So that equals negative 12 over 6, which equals negative 2. So the slopes are the same, so they're parallel. Parallel. Number 25. Write an equation for a line parallel to g of x equals 3x minus 1 and passing through the point 4, 9. So the strategy on this is to find the slope of the line we want and the point that it goes through. Alright, that's pretty easy. It says it's parallel to g of x, so it's got the same slope as g of x, and they've given us the point. And then what we do is we use the point slope equation for a line. Plug in the numbers and we've got our equation. So m, the slope m, is going to equal 3, and the point is 4, 9. Alright, so we've got the point slope equation. Y minus y1 equals m times the quantity x minus x1. Alright, so plug in everything that we have. That's y1, 9, m is 3, and x1 is 4. So there you go. Now you just solve this for y. First distribute the 3 through, you got 3x minus 12. And then add 9 to both sides, you get y equals 3x minus 12 plus 9, or 3x minus 3. Alright? So there's the equation that we seek. Number 27. Write an equation for a line perpendicular to P of t equals 3t plus 4 and passing through the point 3, 1. Alright, so the slope will have to be the negative reciprocal of the slope of P of t, which equals 3. So it's got to equal negative 1/3. Alright, that would be the negative reciprocal. When you multiply 3 times negative 1/3, you get negative 1, which is what you want. And we have the point, so the slope m is negative 1/3. And we have the point 3, 1. So that suggests the point slope equation for a line y minus y1 equals m times the quantity x minus x1. And so plugging in everything, we've got y minus 1 equals negative 1/3 times x minus 3. And then we can distribute the negative 1/3 through, we get negative 1/3 x. And then negative 1/3 times negative 3 is positive 1. Alright, so y equals, oops, got to move this to the other side as well. So add 1 to both sides, you get negative 1/3 x plus 1, which is plus 2. So there is the equation. Well, not quite, because I'm using x's. Really, I should be using t's, because that's what they started with, p of t. So just change it to a t instead of an x. Y equals negative 1/3 t plus 2. That's going to be our solution. Alright, that's technically correct. So it's easy to remember these formulas. They always use x's, it seems, and so you know, it's easy to forget what variable you're using here. Technically, it'll be a t on this one. Now, will your professor take points off if you did that on a test? Maybe, maybe he would, or she would. Who knows? You know, I wouldn't risk it. I would pay attention to those little details. You don't want any points taken off if you can help it. All right, so you can do the work using whatever variable you want, but make sure your final solution has the correct variables in it. All right, that's my advice to you anyway. Would I take off points? Who knows? All right, it depends. Okay. Number 29. Find the point at which the line f of x equals 2x plus 5 intersects the line g of x equals negative 3x minus 5. So to do this, you can set f of x equal to g of x and then just solve for x. That'll give you the x-coordinate of the point where they intersect. And then once you know the x-coordinate, you can use that and plug it into either f of x or g of x to get the y-coordinate. All right. You can use either function because both of the functions intersect at that one point. So that x-coordinate will give you the y-coordinate in either one of those functions for that point of intersection. All right. So we're going to set f of x equal to g of x. And then solve for x. So f of x is 2x plus 5. And g of x is negative 3x minus 5. So let's transpose this term, negative 3x, to that side. So that becomes positive 3x. And then transpose the 5 to the other side, that becomes negative 5. So and then 2x plus 3x is 5x. And negative 5 minus 5 is negative 10. And so x, dividing both sides by 5, x equals negative 2. So now you can use x equals negative 2 in either f or g of x and get what the y value is. All right, so I like the looks of f of x a little better than g of x, so let's use that one. We take f of negative 2. That equals 2 times negative 2 plus 5. That's negative 4 plus 5, which is positive 1. So the point of intersection is negative 2, 1. Number 31. Use algebra to find a point at which the line f of x equals 7/4 x plus 457 over 60 intersects g of x equals 4/3 x plus 31/5. So they had to tell us to use algebra on this? Gee, what else is there that we can use? I know, you can graph these and use your calculator to find the point of intersection, right? Well, as far as I'm concerned, part of the objectives of this course is to help you to be fluent in algebra, not just know it, but be fluent with it, because trust me, you're going to need that fluency when you get into calculus, if you do, right? So this is pre-calculus. So the key to doing calculus well is to be very good at algebra, all right? Because there's a lot of algebra. In fact, that's probably the hardest part of algebra or calculus, is doing the algebra, because you're taking a lot of time to simplify things when you have expressions in calculus. So anyway, let's use algebra. Okay. So we do this just like we did the last problem, 29. Set f of x equal to g of x. The reason they put these nasty fractions in here is to make sure you guys use algebra anyway, right? So they don't want decimal approximations on this one. We have 7/4 x plus 457 over 60 is equal to 4/3 x plus 31/5. Okay. So I'm going to move the x's together and get these constants on the other side. So I've got 7/4 x minus 4/3 x equals 31/5 minus 457 over 60. Alright. So one thing it would be nice to do is to clear these fractions, make them all into integers. A little bit easier to work with. So you get the common denominator of all of these. Here you got a denominator 4, 3, 5, and 60. What's the common denominator? Well, it'll be the least common multiple of all of these. Alright? And if you don't remember what the least common multiple is, that's something you should have already learned back in the old days of Algebra 1. Alright? So you might want to look that up. But you can multiply everything through by 60, and that'll give you some good canceling going on here. And I love canceling, right? So multiply both sides by 60. Alright, so 60 cancels with 4 and gives you 15. Cancels with 3 and gives you 20. And 5 cancels with 60, gives you 12. And 60 cancels with 60, so that just becomes 1. And so now we've got 15 times 7x. That's 105. 105x minus 20 times 4x, which is 80x, equals 12 times 31, which is 372. And then minus just 457. Alright, so 105x minus 80x is 25x, and that equals negative 85 on the right side. Alright, so you divide both sides by 25 to solve for x, and you get negative 85 25ths, and that reduces to negative 17/5. Okay, now we need the y coordinate. So which one do we want to use? I kind of like G of X better. It's got the smaller smaller numerators and denominators here, so let's try that one. So we've got G of negative 17/5. That equals 4/3 times negative 17/5 plus 31/5. And that equals negative 68/15 plus 31/5. Alright, and that equals, well, you can multiply 31/5 by 3/3 and that'll give you 93/15. Alright, so multiply 31/5 by 3/3. So you're multiplying by 1, so you're not changing the value of that fraction, but you are getting the common denominator of 15. So that's negative 68/15 plus, that was 93/15. Alright, so you do the subtraction, 93 minus 68, and you get 25/15. Let me do it down here, 25/15. And that reduces to 5/3. So the point of intersection is x equals negative 17/5 and 5/3. Okay, number 33. For the following exercises, match the given linear equation with its graph in figure 24. And here is figure 24. Okay. So 33 is f of x equals negative 2x minus 1. Alright, now if you look at these graphs, you'll note that the slope is negative 2, the y-intercept is negative 1. Alright, now there are three graphs of the y-intercept of negative 1. That would be D, E, and F. Alright, now which one has a slope of negative 2? Well, none of them do. So your graphs here in the figure do not show the correct answer. If you look at F, that comes the closest, right? But it has a slope of negative 3. Start at the y-intercept, negative 1. And a slope of, you go down 1, 2, 3, to the right 1, and you'll get to that point there. Alright, that tells me you have a slope of negative 3, not negative 2, which is what we're looking for. So the other ones don't have the correct slopes either. Alright, although they do have the right y-intercept. Okay, so the correct line is this, and I did this one on my computer. This is the correct graph that we're looking for. Alright, right there. Okay, that's y equals negative 2x minus 1. Alright, so unfortunately the book's answer is incorrect, or actually the graphs here don't include the correct answer. line F, which is the answer given in your book, is actually y equals negative 3x minus 1. Alright? Okay, so there you go. If you were having trouble with that one, that's why. Alright. Okay, number 35, we have f of x equals 2. Or y equals 2. Alright, well, that's a horizontal line, y equals 2. And, well, there's only one horizontal line on here. And that is the correct one, y equals 2. It's going through y equals 2 on the y-axis. All the points on this line have coordinate x 2, right? The y-coordinate will always be 2. Alright, so the answer to this is C. C. Number 37. F of x equals 3x plus 2. Okay, so what we're looking for is a line with slope 3 and a y-intercept at 2. Alright, well, let's see. We've got 3 lines that have a y-intercept of 2. That would be A, B, or C. We already know it's not C. Alright, we're looking for a line with slope 3 of those 3 lines. Well, looks like A, doesn't it? You start at the y-intercept there. A slope of 3 is the same as 3 over 1, a rise of 3 and a run of 1. So you go up 1, 2, 3, run of 1 to the right. There you go. If it were negative 1, you'd go to the left. All right, but that's it. Or rather, line A is the correct line. Number 39. For the following exercises, sketch a line with the given features. So on 39 we have an x-intercept of negative 2, 0 and a y-intercept of 0, 4. So on that one, to sketch a line, all you have to do is plot those 2 points on a graph paper and just connect the 2 dots with a straight line. Alright, so here's a picture. That would be pretty easy to draw. Just connect the dots. And that's the equation y equals 2x plus 4. The graph of the equation, that is. Alright. Number 41. A y-intercept of 0, 3 and a slope 2/5. 2/5. Alright, so to plot this, you plot the intercept 0, 3. So let's say that's right there. Alright. Okay. So we have the y-intercept, and the slope is 2/5. You could also write that as negative 2 over negative 5. Why? Well, negative divided by negative is positive, so they are equal. But why would you do that? Well, I'll show you in a sec. Alright, so the slope is 2/5. That means rise over run. Rise is 2, run is 5. Alright, so rise of positive 2 means you start from a point on the line, which is this one right here, the intercept, go up 2 units, rise of positive 2, and then a run of 5, that's positive 5, means you go to the right 5 units. So 1, 2, 3, 4, 5. If I had graph paper, this would look much better. Alright. And then you connect those 2 dots with a straight edge. Alright. Now if you say run out of space over here, you can go the other direction by using this expression, negative 2 over negative 5. So you might have more room going this way than you do that way. Alright, so you start at the y-intercept, or whatever point they give you. It can be any point on the line, and then you go down 2, because it's a negative 2. Rise of negative 2 means you go down 2, 1, 2. And a run of negative 5 means you go to the left 5 units, 1, 2, 3, 4, 5. So down 2 to the left 5, right about there. And you connect the dots. Oops, no straight edge, kind of messy. Alright, connect the dots with a straight line, and there you go. It doesn't matter which expression you use, you'll get dots, or rather, yeah, you'll get these points that are on the line, and you can connect them. Alright, there you go. Oh, by the way, let's say you had a slope of negative 2/5. You could write that as negative 2 over positive 5, or positive 2 over negative 5. So you could use either one of these. So if you use this one, for example, the rise would be negative 2, which means you would go down 2 units, and then run of positive 5, go to the right 5 units. Or you could use this one. Rise of positive 2 means you go up 2, and then you go to the left 5 units for your run. Alright, so you can use either one of these depending on how much room you have on your graph paper for either one or the other of these expressions. Alright, so again, they're all equal, so it's not doing any damage. Alright, so that's a nice little trick you can use when you do these by hand. Oh, let me show you the answer in the book.